All right, so I'm going to go on to a clean page because as you can see, I can't write on here. And I'm just going to do problem number 4 and then I'm going to do problem number 5. Okay, so I'm hoping that you realize that this is a proportion. All right, so this is a 1 prop Z interval. Boy, it's been a long time since we've done this, huh? Okay, so let's do the conditions first. Okay, so the first one is random. Okay, and it is stated. Okay, 10% condition. Now, notice here that my population is 2,384. And so we're just interested in, so 50 is less than 10% of 2,384 songs. Okay, and then remember now we have to use success, fail. And it's n times p hat. So we have success, so is n times p hat is greater than 10, and n times q hat is greater than 10. So this would be 13 is greater than 10, and then 50 minus 13 is 37 is greater than 10. And then, so conditions for a normal distribution exist. All right, now I can do the math. Yay! So let's go find p hat, which is 13 out of 50. So it's going to be 13 out of 50 plus or minus. And it's a 90%. Do you remember what 90% is? Is 1.64. Okay, so it's going to be 13 out of 50. 37 out of 50. Divided by 50. Okay, so now I'm going to go to my calculator, so I'm going to pause for a second. Okay, so in case you forget, it's one sample z int. Okay, so I get 1, 5, 7, 9, or you can say 80, 2.3620. Okay, so there's my interval. And A says construct and interpret. All right, so now we have to interpret. So here's my construct. I'm going to interpret. So we are 90% confident that the true proportion of songs played by Lori is between 15.79% to 36.20%. Okay, so let me go to B. And they want to know, explain, okay, is it independent or they want to know with replacement or without replacement. Explain what distinction is not important about this. Okay. So the deal is with replacement or without replacement. Now, if it's with replacement, that means that the first one, that a prior probability, that the current probability relies on the prior probability. And what's the whole thing about it being an independent, right? That is that 10% deal. And so what do? It meets the 10% condition, right? Remember, that is for independence. Another one is that if it is without replacement, if without replacement, The first guy was going to be 1 out of 2. Okay, so it's 1 over 2, 3, 8, 4, and I'm going to go find out what that is. And then remember, if I take 1 away, that's going to be 2, 3, 8, 3. Okay, so let's go find out what these are. 1 divided by 2, 3, 8, 4, and I get 4.19 times 10 to the negative 4, and 1 divided by 2, 3, 8, 3, and I get 4.196 times 10 to the negative 4. And you see how the difference is so small that it's minute, it's irrelevant. Difference is so small. I probably go to another decimal place here. That is irrelevant. Irrelevant. Okay, now I'm going to go do the next guy. Okay, so this is a good one to do because these problems are easy and it's good to have a refresher. All right, and so I have to, again, I don't have room here. Maybe I do. Maybe I can try to do it and erase it. Okay, so let's look at A here. They want to know the probability that selected is a college graduate or obtains information from the internet. And you see how this guy happens twice, so we have to subtract it. So it's the probability that is a college grad or the probability of internet is equal to the probability of college grad plus the probability of internet minus the probability of grad and internet. Remember that? All right, so what do we have? We got 687 plus 693 minus 245 divided by 2500. So 687 plus 693 minus 245. So that gives me 1135 over 2500. And again, you don't have to simplify. That answer is fine. Okay, so let's go erase this and let's go do the next one. Now I believe this is a conditional probability because they say my population has changed, and it's not to everybody. This says if an adult who is a college graduate, so my population is 693, what is the probability that they obtain their news from the internet? So this would be simply 245 divided by 693. Okay, I find C interesting. I haven't seen many free response questions having to do with independence, and it's been a long time since we've done this. So I wrote the equation up here, and so let me write it in terms of what we have here. Remember, this right here is conditional probability. So remember, the A is what my new population was, and that was college graduates. So B is going to be internet. So the probability of internet, given that they are a grad, is equal to the probability of the internet. Okay, well, I found this. This is 245 divided by 693, and the probability of an internet is 687 divided by 2500. Okay, so let's go see if these proportions are the same. So 245 divided by 693, and I get 0.35, and they have to be exactly the same. And then I get 687 divided by 2500, and I get 0.27. So the answer is no, and my justification is all this. Okay, so basically they want to know what kind of test would we do for association, And that'd be chi-squared test of independence. That's the table one. And, or you can just say chi-squared, and my degrees of freedom is r minus 1 times column minus 1. Remember, it doesn't matter which is r's and which is columns. So I have, my rows are 1, 2, 3, 4, 5. So this would be 5 minus 1 times 3 minus 1, which is 4 times 2, which is 8. So that one ended up not being so bad.